Today we're going to start by solving some exponential equations. And hopefully your instinct is already giving you a hint what to do. As we've seen throughout this year, anytime we want to solve an equation of some type of function, we're going to have to use its inverse. We solved a quadratic equation with the square root. We solved simple multiplication with division. We get rid of addition with subtraction. We learned in our last lesson we get rid of logs when we have a logarithmic equation by exponentiating both sides, because logs and exponentials are inverses. So we're going to use that same thought process here, but in reverse. If we want to get rid of an exponent or solve an exponential, we're going to need to take the log of both sides. And that's where we're going to start here. Whenever you have an exponential equation, we will take the log of both sides. And that's where we're going to start. And I'm going to highlight that what we're talking about here is the common log. I'm not going to take log base 3, log base 9, or anything like that. We're just going to stick to the common log. So I'm going to write that out here. The common log of one side equals the common log of the other. So log of 3x equals log of 11. And that's a little bit weird because the log base 10, right, our common log, isn't exactly the inverse of 3 to the x. It should be log base 3. And you're right if you're thinking that. It's not really going to work that way the way inverses normally do. The reason why we did that isn't to cancel anything out. It is a bit sneaky. If we want to get our exponent out from, sort of up above that 3, if we put it inside of a log, we can now use the power property to pull that exponent down in front as a coefficient. And so that's what we're going to do next. Pull down the exponents. And pull down is not a very mathy term. Sometimes there'll be more than one to pull down. So in this case, we'll pull that x in front. So it's x times the log of 3 equals the log of 11. And what we've done is solved the problem of having a variable stuck in an exponent. Well, we've got it unstuck. It's now out of the exponent, and we can solve using whatever normal method of solving we have in front of us. In this case, it's a super easy method of solving. It's one of the ones I mentioned a second ago. That's just multiplication. X times log of 3. If I want to make that be just plain old x, I will just divide both sides by log of 3. Remember that log of 3 is just some number between 0 and 1. I don't really care what it is. But I can divide by it, and I can write log of 11 divided by log of 3. Everything is simplified. That is my answer. So those are our 3 steps to our process. We'll try another one as an example. We'll start by taking the log of both sides. So log of 9 to the x equals log of 45. And again, it's not to cancel anything out, but it's just to let us pull the exponent down in front of the log, which gives us x times log of 9 equals log of 45. And we'll finish that we'll finish the solving part by dividing both sides by log of 9. But there is an important piece to realize here. We're not quite done here because we can simplify this. Be careful when I say that. I don't mean that you can reduce the fraction 45 over 9. That you definitely can't do. This doesn't say 45 over 9. The log of 45 divided by log of 9 as a fraction can't be simplified, but each log by itself can be. Because 45 is equal to 5 times 9. So I can rewrite that as using the product property as the log of 5 plus the log of 9 over the log of 9. I don't know why I wrote a 3 when I meant to write a 9. Although I kind of do know, because the log of 9 can also be simplified. 9 is 3 squared, so what we can do is take that log of 9 and rewrite it as 2 times log of 3. And we're going to do that to the log of 9 in the denominator also. And of course, I can't reduce that fraction because the numerator has addition in it that can't be broken up. But at least now all of my logs are simplified. I will say that most of the problem, most of your job, is to get to here. The last bit about simplifying is far less important than getting that solution. So while the boxed answer is the final answer, most of your work is done by the time you get to log of 45 over log of 9. Okay. And I will do one more here, because this one does get a little bit trickier, but the logic is the same. We're still looking at an exponential equation. We still want to get those exponents out. We want those x's out of the exponent, so we need logs to do it. So I will take the log of both sides. Log of 7 to the x minus 2 equals log of 5 to the x. And in this example, you can see why I said before you can't just take the log base 3 of both sides to cancel out the 3 to the x. Because if you have a different base on both sides, that's not going to help. So using a common log allows us to do the same thing on both sides, where in both cases we're going to take the exponent and pull it down, take the exponent and pull it down. And now, even though we don't have, we've got logs of different arguments on either side, we still have our x's outside of our logs, and that's what we wanted. But we haven't quite done the hard work yet, because now solving this equation is a little bit trickier than the other ones, because x minus 2 log 7, you might be thinking, well, how am I going to get that log by itself? So how can I get that x by itself? What we have to do, and a great trick, is to imagine it was a little bit easier. Imagine if it just said x minus 2 times 7 equals x times 5. Well, you know from Algebra 1 what you would do here. If you want to get these two x's together, you first have to break apart those parentheses. And then you'd be able to move one x over to the other side. So we're going to use that same logic here. We're going to break apart the parentheses, distribute the log of 7. Now, I can't actually multiply the 2 times the 7, so it's just going to look like 2 times log of 7. And now that we've gotten the x's out of the parentheses, now I'm free to move from one side to the other, so I can take this x log of 7, and I should subtract it, not add it, to move it over to the other side. Notice how I'm writing it off to the side a little bit because they're not like terms. So I can't exactly just combine them. But what I can do, and this is similar to an example we've seen recently, when I have that x log of 5 minus x log of 7, I can factor out the x. Which leaves the x almost totally isolated. All that we would have to do now to get the x by itself is to divide both sides by that other factor, log of 5 minus log of 7, which I know looks weird. Not by x. I know it looks weird and complicated, but negative 2 log of 7 divided by log of 5 minus log of 7, it's just some number. And everything is fully simplified because the the arguments of those logs, the 7s and the 5, they're prime numbers. They can't go anywhere. That is your final answer. And I do want to remind you the similarities here between what we did over here, breaking apart the parentheses and getting those x's together so we can get the x alone, to what we did in a much easier example that you're more used to, breaking apart the parentheses so we could get the x's together so that way we could get the x alone.